we're going to go ahead and start off by having you guys do a small little intro, little activity, and Marty's going to introduce that.
Okay, what I'm going to do is I'm going to go around the room and I'm going to ask you for your shoe size and your height. So hopefully you could know those off the top of your head. If anything, get as close as possible. Shoe size first.
8.
An 8. And height? 5'4". Okay.
8.5,
8.5, 5'4".
5.
Ooh.
All right.
All right, there we go. Got an outlier. And me, I'm 5'9" and I'm about a 5'5". So what we're talking about today is best fit lines for a plot of data, and we're going to talk about different types of correlation. So right now, just kind of keep this off to the side. Notice, I don't know if you noticed, but I have different colors on here. Maybe we'll wrap something up with that at the end. Right now, I'm going to kind of high-five it over to Gino.
We're going to be working with real data, and you know, I would start off by probably having a little conversation on what real data is. So I'll ask them, well, what is data? What's real data? And they'll come across and they'll start saying things, I don't know, they'll say real numbers that are involved in the real world somehow. And the example that I have up here is involving a discus throw over the years, since the early 1900s to now. Men and women have gotten stronger, and the discus throw has gotten much longer over the course of the years. There are several ways to find the line of best fit. We're going to be using a graphical method, so we're not going to be doing this algebraically without drawing pictures. We're going to go ahead and choose 2 points that are exactly on this line, and the 2 points here that are going to be on the line might be, you know, I don't know, maybe this point here or that point there, any points you want. And I'd probably take a little pause here and ask them, you know, which 2 points would you use, and see if anyone can kind of point out a point. And then I'd go into the discussion on the years versus distance, and see if maybe any conversation strikes up. So the whole objective of today's lesson is for us to come up with the equation of that line. That line is going to be a line of best fit, so we're going to come up with an equation. And we've been working with equations, so we're going to go ahead and start using our little strategy. And the 2 points that I've chosen is this one here and that one up there. You can choose any 2 points on a line, but we're going to go ahead and choose any 2 points. And they don't necessarily have to be the red dots, those points. They could be any points on that line, because 2 points determines a line. I mean, with any 2 points, you can go ahead and find the equation of that line. So choosing any 2 points, we would go ahead and proceed by finding the slope. And we've talked about different methods of finding the slope, either by drawing a triangle using rise over run, counting those units, or by using the slope formula. And so we're going to go ahead and use that slope formula. And we've talked about the points representing x1, y2, and x2, and y1. So we go ahead and we substitute those values in, and we take a little pause here. We go through that, perhaps on a warm-up that was already on there. Perhaps last night's homework that was already on there. So this is depending on a lot of previous knowledge. So the slope is going to be about 1.05. And if I wouldn't turn it into a decimal myself. I would leave it in terms of a fraction, even if it's not reduced, as long as I have a numerator. And using the slope-intercept form of a line, we go ahead and substitute the value of m, which is the slope, and put that in for the value of n. And you know, a lot of little explanation that you can do here. Substitute in x and y. I would pause at this moment and say, where did 8 and 138 come from? And why didn't we choose that other point that was probably, if you remember what it was, whatever that other point was? I'm sure that if we would put this in here on the side, we would end up getting the same value of b, which is going to be our y-intercept at 130 that you were talking about. Simplify that by subtracting 8.5 or 8.4, and we get 129.6, which is approximately where that line began. And I can hit backspace, 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 and show them, look, the value of b is always going to be wherever that line begins. And it's important for them to see that that b represents that point. And yeah, 130 might not be exact, but that line is not exact either. So it wouldn't make a difference if you put 129.6 or 130. It wouldn't make a significant difference. So, what I'm saying. So writing the equation of that line of best fit, we would end up substituting the value of the slope, 1.05, and 129.6, and we end up getting this line that represents the pattern of points, or the average pattern, the line of best fit. And so what we're seeing is that over the years, there's been an increase in distance, and that line of best fit can be represented here. So X, if you go back to the graph, represents the years. So for any given year, assuming that this pattern is going to be continuous, we can find out the distance for any given year. So if we say X is 9, that's 1909, we can find the distance in 1909. Say you want to find the distance of the discus thrown in the year 2027. That was not part of our data, but using the line of best fit, we put not 27, because 27 would represent 1927. What about the year 2027? That's 127. We put that in here, and then find out what Y would be, which would be the distance for that given year. So in most years, the winner of the discus throw was able to throw the discus farther than the previous winner. And we end up having more examples that are all roughly about the same thing. We turn it over to them, give them the practice that they probably going to need on their own. And there's other correlations, other relationships that are negative. The points are going down from left to right, and we talked about this when we did that activity, if you remember it, those cheerleaders. Negative correlation. And then we have patterns that really don't determine positives or negatives. And so we say that any points that are kind of scattered around in every single quadrant here wouldn't represent correlation at all. Okay, so there is no correlation here. You got a line going this way, you got a line going that way. So you got the three types that we just talked about. We go through these. Let's move forward. Click, click, click.
All right.
And then I probably stop and start doing some guided practice with them. And our textbook kind of was very good, actually. Mr. Hanlon talked about how you should stay away from 1 through 32 even, or 2 through 32 even, and start off by maybe writing down a few things that would require them to use a textbook.
A cool thing to wrap up the lesson as well is kind of go back to your anticipatory set and show them, now that we've collected all this data, you know, can you draw a line of best fit here? Do you see a positive correlation? Do you see a negative correlation? Do you see no correlation? I'm going to leave that up to you guys. What do you think?
Correlation.
Kind of looks like there's a positive correlation going on. Down here it's kind of, you know, going on a little weird. What might cause that? What might be our problem? Not drinking milk. What's wrong down here, maybe? What could we have done in our experiment differently that may have, you know, we could see a better line?
Marry a tall white guy.
Marry a tall white guy. Could we had a small sample size. That's one problem. We only had a few people in this room. If we had a lot more people, do you think there'd be a stronger correlation, that the lines might be a little closer together? Maybe if Mrs. Hoyt was a better grapher and drawer of graphs, maybe that may have been an issue. But it looks like there's a strong correlation, a positive correlation. I could maybe draw a line here. Any questions on the lesson before we tag team?
Good, thank you. Good job, good job.